Assalamu alaikum guys, I am Ghazanfar, your chemistry tutor, and today we are going to talk about the Simmons Smith reaction. Simmons Smith reaction is a callitropic organic reaction in which there is formation of cyclopropane derivatives takes place when the alkenes are treated with diiodomethane in the presence of zinc copper alloy. So firstly we discuss the general reaction of Simmons Smith reaction, in which an alkene is treated with diiodomethane in the presence of zinc copper alloy. In the presence of zinc copper alloy, then there is formation of cyclopropane derivative takes place. Cyclopropane derivative is formed when the alkene is treated with diiodomethane in the presence of zinc copper alloy. So this is the general reaction, and now we are going to discuss the mechanism of Simmons Smith reaction, in which there is formation of organo zinc carbenoid takes place. Organo zinc carbonide formation takes place. So we have diiodomethane and treat it with zinc copper alloy. Then there is formation of organo zinc carbenoid. This is called organo zinc carbenoid. We have an alkene that is treated with organo zinc carbenoid. So in the first step, these pi electrons attack on the electrophilic carbon. Iodide leaves the carbon and then undergoes the electrophilic addition. These electrons attack on this electrophilic carbon, and a transition state is formed. Because it is a callitropic organic reaction, so there is a transition state formed. This bond breaks, that is represented by the black dots, and the bonds that are represented by the red marker are the new bonds that are formed. These new bonds are formed, and the bond of carbon and iodide also breaks, so it is represented by the black marker, and the bond of carbon and zinc iodide also breaks, so it is represented by the black marker, and a new bond is formed between this iodide and zinc iodide, that is represented by the red dots. So this transition state is formed. Three new bonds are formed and three previous bonds break in this Simmons Smith reaction, and we get the final product, that is our cyclopropane. This cyclopropane is formed when the diiodomethane is treated with alkene in the presence of zinc copper alloy. So this is the mechanism of Simmons Smith reaction. Is a stable compound, zinc iodide. Now we are discuss some examples of Simmons Smith reaction, and the important point is that the attack is always occurs at the less hindered side when less number of bulky groups are present. So we have organo zinc carbonide, organo-zinc carbonide is added. So attack is these electrons, pi electrons attack on the electrophilic carbon. Iodide leaves this carbon and then undergoes the electrophilic addition. These electrons attack on the carbon that is less hindered, where less number of bulky groups are attached. So since this site is less hindered and these two bulky groups are present here, that's why the electrons does not attack at the hindered site or the where bulky groups are present. So these electrons attack on this electrophilic center, and there is formation of cyclopropane. And zinc iodide also formed here. Zinc iodide. In this example, this site is a hindered site because the bulky groups are present and there is steric repulsion present between the bulky groups. So these pi electrons attack on this electrophilic center. Iodide leaves the carbon, and these pi electrons, and these electrons attack on the electrophilic center, and there is formation of cyclopropane derivative. These electrons does not attack on this side because this is hindered side due to the presence of bulky groups. And zinc iodide also forms here. So this product is formed. In the next example, these electrons, pi electrons attack on this electrophilic center. Iodide leaves the carbon, and these electrons attack on this electrophilic center. These electrons do not attack on this center because there are bulky groups present. So due to the steric repulsion between these bulky groups, steric hindrance generates. That's why the electrons attack on this center, and there is formation of cyclopropane derivative and zinc iodide. In the last example, we will observe that these pi electron that are represented by the green marker attacks on the electrophilic center. Iodide leaves this carbon, and these electrons attack on this electrophilic center, not on this electrophilic center because there is bulky groups are present at this site, and due to the steric repulsion between the bulky groups, steric hindrance generates here. That's why it attacks on this less hindered site, and there is formation of a cyclopropane. There is formation of cyclopropane derivative, and zinc iodide also forms. So these are some examples of the Simmons Smith reaction in which cyclopropane derivatives are formed when the alkenes are treated with the organo-zinc carbonide. So this is all about the Simmons Smith reaction.